with the makeup for the final, after the final. Okay? And usually it can be a little bit harder than the actual exam, but you have had a lot of time, the semester is over, then you make up for that and study and take it after the final. Okay? So unless you really have a difficult health problem, we don't postpone exams. We don't go to makeups. Okay. The person to contact about health reports is Dr. Emrah Kalemci. His email, everything is here. Here, finally, is the course schedule. We will follow this roughly. Okay. The course has 3, or rather 4 modules. First, we will do mechanics, motion. And related to that, we will do statistical physics, which means how to understand the motion of lots of little things in a gas. Okay? We will derive that. We will derive the gas law, PV equals N times the temperature, from Newton's laws. Okay? The second module is electricity and magnetism. We will learn about, of course, electric and magnetic phenomena. At the end, we will learn how electric and magnetic fields, electric and magnetic phenomena affect each other. And because of that effect, changing electric and magnetic fields make waves which propagate. Where in empty space, even in vacuum, this can go, and that's light. Now, this is something that is usually not done in first-year university courses. We try to do it graphically with pictures, but we want to make a complete picture so you understand why is it that we have light, radio waves, etc. That is the electromagnetism module. And the final part of the course is quantum mechanics, because all of our modern understanding of the world, what matter is made of, okay, why is this piece of wood so rigid, all of this is really based on quantum mechanics, which is very strange. You have all heard of it, but we would like to give you some understanding of, or some exposure to really how strange it is. Because what it says is, all the little particles, the electrons inside the atoms, are really waves. They are both waves and particles. This sounds very strange, but without this, it is impossible to understand anything about the physical world. So, this is important, even if you don't do science, to come out of your first year, let's say, only science course, with some idea about what modern physics is and what matter is really made of. Okay? So that's quantum mechanics. So it roughly breaks in terms of exams. The mechanics part is the subject of the first midterm. The electricity and magnetism part is the subject of the second midterm. And the final will include everything, but of course it will be more weighted for quantum mechanics content. Okay? Any questions about the course organization, about the syllabus? Okay, it's very clear. Okay. Now, in this first lecture, I will start by discussing What is science? What is science as a way of thinking? What is the scientific method? What is its importance? So this is a philosophical question. It emerged in the development of civilization. The development of science went in parallel with certain developments in thought in general, in philosophy, and also, of course, it went hand in hand with developments in technology. But if you think about it, what are the basic philosophical beliefs of a scientist or of a person who wants to do things scientifically? The first thing is something very simple but fundamental. One believes that there is an external world. Dış dünya. What does that mean? It means when I think and when I see the world around me, my primary consciousness is just my own mind. There are philosophies which assume that there is nothing other than my mind or my spirit or whatever. And everything that I seem to know about others is an illusion. This is very nonsensical, very absurd, but it is consistent. There is no way you can test this. Okay? Now, science is most fundamentally just the antithesis of this. It says, there are things outside my head. And what is the argument for this? Because I can learn about the external world by observing it, by looking at it, by having certain experiences and not repeating them. If I fall on this step, then I'm careful the next time. That's how we learn, since we are babies, right? And what I conclude from my observations about the outside world, when I talk to you, your experience under the same conditions is the same. Of course, it's like the Matrix film. It can be a very contrived situation where there's just my mind, and the fact that you report, you see the same things is also part of my dream. You can go on like that. But it's a belief that this is very nonsensical. Okay? And I believe there really is an external world. And the reason I agree with other people when we discuss our experience under the same conditions is because we all live in the same external world, and if we approach it in the same way, it does the same things to all of us. So there's something out there that is something that I can learn about. And I can learn as a social process. I can share my learning with other people, because if they do the experiments or observations under the same conditions, they get the same answers. So we can exchange our experiences, check on each other's knowledge, okay, rather than taking it, oh, this guy is a big professor, whatever he says must be right. Or she's my mother, if she says, if you don't wear your scarf, you'll get a cold, whatever. She's my mother, she knows. Well, maybe it's not right, What do you do then? Is check. Okay, you go out without a scarf, and nothing happens to you. Maybe. Because you are that type of person, it doesn't matter for you, okay? So you have an empirical, experimental basis on your own. And then you can check that with other people, what happens. So you don't buy, you don't take things for true on the basis of authority, because it is written in an important book, or because somebody who is very wise has said it. Okay. Now, if you think of this, so the first thing about the knowledge basis of science is that there is an external world. Second thing is something that I could call the objectivity of this world, because under the same conditions, the same experiments, same observations, done by anybody, give the same results. If these two things were not possible, were not true, of course,